Hello, good afternoon, Internet. Welcome to another NL Math Man Math Help stream. Glad you could join me for today. I'm gonna boot up my headset here. You got some we got some effects going on. You see that? Oh, look at that! Look at that! Just look at see the steam rising from my mug. Yeah, what a see we got some real. This is some special effects here. These are practical effects, is what this is. Yeah, yeah, that's the good stuff. It's not. This is not added in post with CG. Look at that. See that? Yeah, it's steamy in here. Mm-hmm. Look at that. It's good stuff. The problem, the problem though, the problem is that Twitch chat. I gotta tell you, this is. It might be day 10 of math tutoring, but it's day one. It's day one of instant coffee. I gotta tell you, day one of instant coffee. I don't know how I'm holding up. It's it's a bit rough. It's a bit haggard, is what I'm saying. Although, although I have been remiss. I gotta tell you, Twitch chat. I have been remiss. I mentioned before about the finest of Newfoundland delicacies for food, and I mentioned like catagrat, and I mentioned Towdens, I mentioned pea soup, which I was having at the time. And if you remember that, this is a callback, right? But today I have what is actually I had forgotten. Okay, I have what is actually the unquestionably the best um, delicacy from the island of Newfoundland, from our cuisine. You ready? You ready, Twitch chat? Ready to see what this is? I'll tell you what this is. Look at that. See what that is? It's got a bite out of it already. Ah, anyone from the island should know, right? Let's hope. Even townies should probably be aware what this is. This is a slice of toast with partridge berry jam on it. Yeah, that's right. Partridge berry jam. Now, some people call it lingonberries, but those people are wrong. Okay, it is partridge berry jam. Partridge berry jam, best darn food ever known to man. Right? Mm. Well, that's good. Got to keep my antioxidant level up. Twitch chat. Got to keep those antioxidants going strong. Right? I mean, right now is not the time when you want to be faltering on your intake of delicious. Oh, there we go. Be faltering on your intake of delicious antioxidants for sure. This is not the time. Okay, so over here, you'll notice off to the side there, we've got Christmas at the cabin, right? Why have I got a Christmas picture up? Why have I got a Christmas picture up on April the 3rd? Well, in Newfoundland now, we've been doing, people have been keeping their Christmas lights up in the night. Like some people out behind me in the apartment building just behind my house are doing it. Sort of a nice gesture. You know, if you've got, if you got the lights left up, it adds a little bit of color, a little bit of vibrance to the night. The nights are the nights are weird here these past days. It's misty. It's misty and foggy in St. John's a lot, but boy, it has been eerily quiet outside the nights. Let me tell you, these past few nights, just to step outside my door and it's like, yeah, it's like something out of a movie, man. It's a different world. Um, just how quiet everything is and how I don't know how misty as well. But we get that anyway, just not the quiet. But I gotta say though, overall, I think I'm really proud of the reports that I've been hearing about how the province is doing with our shelter in place and social distancing and stuff. So, like the title says, we're out here flattening the curve, one little bit at a time. And yeah, I hope you'll join me to keep yourselves busy, to do some good math work while we're gonna stay the fuck home, as they say, right? Sorry, this is a G-rated stream, right? I get one. I get one F-bomb per stream. Well, that's PG-13. Maybe I should change it down below. This is a PG-13 stream. Hey, Anna Shelley, how you doing? Good to see you. I will start off with some questions for you here today. Once I finish my toast and jam. Boy, this is good. Also, after the stream is over, I'm going to have a little bit of a talk about some educational games. Ones that that's really my wheelhouse. A lot of my teaching um, in sort of traditional classrooms has involved games extensively, and I would like to talk about them a bit, talk about some of my ideas behind it. Just a self-indulgent kind of thing, but it should be a bit of fun. And I'll also go through and I'll display this here, which is one of the originals. This is one of my original decks of Mathemagic, a game that I made up, um, and I used it to teach kids. I was in Surrey in UK, and it was extremely successful in the classes that I used it in, and a lot of fun for me and for the students. So I'll just go over some of the ideas that I have behind that, and over the next few weeks, we'll on Fridays we'll talk a bit more about it. Maybe I'll even get to show playing some games. Might even get on to showing my current version of the game, which has evolved, continued to evolve and change extensively since the time that I did it actually in an elementary school classroom. But anyway, let's switch on over here now. Switch over to a distant display. Oh, that's nice. Look at that. It gets the furnace. It gets the furnace right there from the cabin. Isn't that cool? Right? I do. We'll just talk about this picture for a brief second, actually, before I get started. This is, of course, a wood stove over here, right? Look at that. And I use the wood stove when I'm at the cabin extensively for cooking stuff on top of. I think this might have had a turkey on top that I brined and then was putting on for a slow cook uh, on top of the wood stove, and then I was going to switch it to the charcoal afterwards. I believe that's the time that's shown here, and let me tell you, that turkey was turkey was good. And we got our the SpongeBob stocking over here. Look at that. That's some good internet cred. Some good memeing, right? And this was a this piece of this was like a tin metal art that my parents found randomly while out walking their dogs in the woods. It's a super scavenged real picker. The real pickers, right? It's a real picker item. But it was a great little piece of sort of tin art for an ammunition company, right? It's kind of trendy stuff for pickers, as far as I'm told. Anyway, without further ado, let's get over to the math. I am going to start off like it says here with area of regular and irregular shapes. So Renetta, if you are there in chat, I will start off with the ones for you. So these are going to be just a few questions that I have picked out of the set that you've submitted that I'm going to be going over today. Oh, might need a bit more paper. Might need a bit more paper today. Okay. So we're going to start off with page 174. That's the page that's being shown up there in the corner. Page 174 of Prism Math Blue. All right, there we go. So move that guy over a touch so we're not seeing the edge of it. That's good. So Prism Math Blue, page 174, number 6 I'm going to do. So let me scroll down a little, because I'm going to be dealing with number 6, the one at the bottom of the page there. So Prism Math Blue, and it's going to be page 174, and this is number 6. Okay. So, which has the greater perimeter, the square or the circle, and how much greater? Well, this is what we call inscribed shapes, right? This was one of the topics that I was going to get to today, as we saw on the intro. And what do we know about inscribed shapes? Well, there's a whole bunch of geometry that you could see later on if you went onto it, talking about sort of the properties of some shapes being inscribed in others, and sort of the way that the amount of area changes, right? Or how much area you lose, say, like in the parts outside. But we're going to figure out right now, basically, is how much area is left over when we put the biggest circle that we can inside of a square. So that's what an inscribed shape is, right? An inscribed shape is simply the largest, say, imagine this circle was drawn properly, which it's not going to be, not even close. But imagine this was a perfect circle here, and this was the largest perfect circle we could fit into this square, right? And this square, like we see here, is 3 meters, so it's going to be 3 meters from this side to this side. So that means, well, what do we know about the circle now? We know that the square rather. The area of a square is just going to be the length squared, right? Because we're already saying it's a square, or just length times width, right? But the area here is going to be 3 squared, which is going to be 9. So the area of the square we know to be 9 That's meters, right? Yes, 9 square meters. The circle now, well, what do we know about the circle? Well, one thing we know about the circle is that the diameter of the circle is going to equal 3, right? Because we know that the distance from one side to the other going through the center is going to be 3. So we know that the radius is equal to half the diameter. So the radius is equal to a half of 3, or the radius is equal to 1.5. Now that we have the radius is equal to 1.5, we can figure out the area of this circle, right? So the area of the circle is going to be pi radius squared. So that's going to be pi times 1.5 squared. That's going to be pi times 2.25. And that is going to be exactly 7. No. So it's going to be pi times 2.25, 7.07. 7.07 meters squared. Right? So we know now. Oh, sorry, I'm doing the area, aren't I? Oh my goodness, my mistake. My mistake. Oh well, I'm going to carry on doing it. I'm going to carry on doing this one because this is a topic that we do need to know. I only just noticed. Boy, this is real scuffed, isn't it? The very first question today. Just chat, the very first question today, and the teacher's already messing it up. But anyway, the area of the, we'll call this the area of the gap, is going to be 9 meters minus 7.07 meters. So that's going to equal 1.93 meters. So what that tells us is if we were to look at this area here, plus this area here, plus this area here, plus this area here, that area will be 1.93 meters. Now that's a super valid question. You could indeed see something like that on a test, for example, but that's not what it was asking here, actually. Here it was asking for perimeter. So pretend I did this correctly. So the perimeter is a distance around outside, of course, right? So the perimeter of the square is going to be 3. There's a 3 there, a 3 there, a 3 there, and a 3 there. So we can call that 3 plus 3 plus 3 plus 3, or we can just call that 3 times 4. 3 times 4 works just fine. So the perimeter is going to be 12 meters. And now for a circle, we don't find the perimeter, right? I mean, we do, but we don't call it that. We call the perimeter of a circle the circumference. Since the circumference is the perimeter of the circle, we know the circumference is equal to pi times the diameter, right? So the circumference here is going to equal 3 pi, which will be exactly 9. 3 pi, no, 9.42. Right? So then, which one has the greater perimeter? Where to find the greater one? The greater is obviously the square. We knew that because it was the shape outside, right? The inscribed shape has to be smaller than the shape that it's inscribed within. Like it's the only way that it would fit, right? But here now we're going to just have 12 meters subtract 9.42 meters, which is going to equal 2.58 meters. There you go. 2.58 meters, that gets us there. Okay, so that's 174, question number 6. I'm going to bounce on now to 2 pages later in the book, page 176. And I'm going to do page 176, number 6 as well. Okay, so we've got that up there in the corner. That's the bottom one down. So that one is the circumference of the circle is 9.72 meters less than the perimeter of the square. What is the diameter of the circle? What is the radius? This is a good question. This is a, think a little bit outside the box sort of a question. Right, so this is now going to be page 176, question 6. I'll do that over here in blue. So, circumference of the circle is 9.72 meters less than the perimeter of the square. Well, how do we find the perimeter of the square? So perimeter of the square is just going to be 4, and there's 4 4s, so it's going to be 4 times 4. So the perimeter of the square is going to be 16 meters. Easy, right? So the diameter of the circumference of the circle is 9.72 meters less. So we're going to have 16 minus 9.72, and that's going to be 6.28. Right? 6.28 meters. Let me just make 100%. Oh, I have a message. Hold on. Let me. Okay. Never mind. I'm being pulled in a whole bunch of directions at once. Of course, that is how this college teaching job goes. Also, how the streaming job goes. So it is kind of similar, huh? 16 minus 9.72, 6.28. Yeah, great. Okay, so it's 6.28 meters. So I need to zoom my cam out a touch so I can fit my full sheet. There we go. So now the diameter is about what? The radius is about what? Okay, easy enough. So now we know that circumference, we know the circumference is equal to pi times the diameter, right? Pretend I drew that pi correctly. So we know that 6.28 is equal to pi times the diameter. 6.28, where have we seen that number before? 6.28 sounds like double 3.14. So 6.28 divided by pi is equal to the diameter. So the diameter is going to be pretty much exactly 2. Now, in this course, you're told to use 3.14 for pi. So in this course, they would be asking you to give exactly 2, not 1.999. So I am going to say 2 equals diameter. So that's 2 meters. And of course, if diameter is 2, we know that radius is equal to a half the diameter. So radius is equal to a half of 2, or the radius is equal to 1 meter. There we go. Right? So that is page 176, question 6 of Prism Math Blue. Super good questions because it's taking a lot of the steps that you already know how to do and sort of combining them maybe in a bit of a different way than you're used to. But that's a totally valid question to see on a test or something like that. You would definitely, when I say something's a good question, it doesn't just necessarily mean that, oh, he really likes math for some reason. Well, when I say it's a good question, the translation there means that that's the kind of question that you would see on an evaluation, on a test or something, right? So, knows, right? That's what they say. Now, 178, question 2. Let's jump on over. Page 178. So this is still Prism Math Blue. And this is, all right, it's for math. It's for math 2017, I believe. But the nice thing about these courses is they're so fundamental that anybody doing the later courses will still need to know these topics. And they carry on being relevant, is what I'm saying. Everything you do in Prism Math, with very few exceptions, is an important topic that we return to later. So 178, question 2. A square picture measures 14 centimeters along each edge. What is the area of the picture? Now this one is relatively straightforward, but just the way it's written sometimes can be a little confusing. So this is page 178, number 2. So when in doubt, draw it out, like I always say. Whenever I know it takes a minute or two longer, boo friggin' who. You can afford the time, especially on tests, especially with the way we're doing them now, right? Right? You got your time limit. You got your time limit for the test, but you can budget your time accordingly. You know how this goes, right? But if a picture is 14 centimeters along each edge, well, what do we know about it? We know this is 14, this is 14, this is 14, and this is 14. Easy, right? So we know that the area, because we're asked for the area of a circle is just, say, the width of the length squared, right? So here it's going to be 14 squared. So it's going to be, what is that, 198? 14 squared? 196. Good thing I checked. 196 centimeters squared. That's it. That's it. That's all there is to that one, boy. Right? Right on. Page 180. 180. Now, this is a good one. Yes. Okay, there's 2 questions I want to solve on this page. Okay. So let me scroll back up, maybe zoom out a touch. Zoom out a touch so you can see the numbers there along with it. I've had to crop these ones a little bit as you're probably seeing because like I said before, I don't have a digital version of this book. I actually only have the answer key, so I gotta kind of take these and then black out the answers. Because I've had some crafty students telling me they can see entire answers to pages. They really shouldn't have spilled those beans. I mean, I knew you could. I knew you could, right? Like, but that kind of means drawing attention to it. Kind of means I gotta make sure it doesn't happen again. Anyway, it's good. It's good. It's good to have honesty. For honest students. Honest students are worth their weight in, well, maybe not gold, worth their weight in N95 masks. It's a bit grim. Um, so this is page 180, question 2. Suppose both the base and the height of a triangle are half the length of those in problem 1. All right, well, I guess we got to do problem 1 first then. Problem 1 it is. Okay. We're going to do problem 1 first. The base of a triangle is 6 meters long. The height is 9 meters. What's the area of the triangle? Oh, well, that's a tough one. Drawing a triangle is tough, though. So the height is 9 meters. The base is 6. Don't mind my drawing. The proportions are way off. But what's the area? Well, the area is, of course, a half times the base times the height, which is going to be 3 times 9, which is going to be 27 meters squared. Sorry to be distracted there, Twitch chat. Okay. Just checking to make sure that everything is copacetic. Let's see, number 2 then. So if I carry on to number 2, I'll do it right here next to it in the same color because it's really linked to it. Suppose both the base and the height of the triangle are half. Oh, both of them are half. Well, if both of them are half, what can we do? Can we just go ahead and half this? Can we just save ourselves a bit of work and just take half of this number? Say that it's going to be, I don't know, was it 13.5? No, you can't. You absolutely can't. Because you're not halving one thing. You're halving two things. Right? If you halve two things, that's the same as taking a quarter of something. Let me show you. Right? So both these dimensions, those base and the height, are both half. Right? So instead of 6, this is 3. And instead of 9, this is 4.5. Right? Because those are both half. So now what do we get? The area is equal to a half, the base times the height. The area is equal to a half, 3 times 4.5. Well, 3 times 4 is 12, and a half of 3 is 1.5, so that'd be 13.5. So a half of 13 is 6.5, and a half is a quarter, so it should be 6.75. 6.75 meters squared, right? Let me see if that's right. Yeah, there you go. 6.75 meters squared. Don't understand 3D on page 85. Sure, Esther, yeah, I'll get to those after I finish these Prism Math blue ones. I've got, I think, 4 more questions to get through these ones, and then I will bring up 3D on page 85. So that is Math 3102A, page 85, and question 3, dimensions. Okay, no problem. So carry on with this one now. 180, I want to do question 5 on this page. Now, to trot out my old phrase, this is a good question. This is a really good question. Nudge, nudge, wink, wink. Right? You're very likely to see something like this again. Maybe not on this test, but soon and for the rest of your life. Not for the rest of your life either. Definitely not for the rest of your life. Oh, my mic audio. Maybe I got to turn my mic audio down a touch. It looks like my laughter is pushing me up into the red. Push me up into the red. There we go. Maybe I'll tone down the mic a touch. Okay. Number 5. Suppose the colored region is removed from the drawing at the right. What is the area of the part removed? And what is the area of the part that remains? Oh, interesting question. Now I'm not really going to use my stencil here. I would like to use this as a stencil, but it's going to be too small of a triangle to really show what we got going on. So I am going to use this as a stencil for a right angle, though. Again, right? You can use it like a square. I had my talk about that already. I really didn't understand that when I was a kid. My dad called the thing a carpenter square, and it was a triangle. And I was like 6 years old, and I was like, Dad, I don't know, buddy. Like, I'm pretty sure. I know you're an adult and all, but I'm pretty sure that's a triangle. It was tough. It's tough to understand that part. So what we've got, right? Line going across here. Oh, I've flipped mine. Doesn't matter. So this is 4 centimeters. This is a right angle. It's important to know. They should have also denotated that this was a right angle, really, but whatever. So this is going to be 2.4 centimeters here in the middle. This is going to be 6 cm, and that's going to be from, I'm going to draw an arrow just so that we are 100% aware of where the 6 centimeters goes from there to there. And then the 4 centimeters is from here to here. So this one is 4 centimeters there. Okay. And we're trying to find what is the area of the remaining part. All right. So what we are looking for, we're trying to find this area, right? But in order to find the red area, we're going to first need to get blue area. So I'm going to write down trying to find red area, but we need blue area first. Why? Why do we need the blue area first? Well, it's because, again, like the compound shapes that we see in other courses, like the irregular shapes that I'm going to talk a little bit about actually on the very next page here, just like irregular shapes, we can't get the area of this section here just on its own. But what we can do is we can get the area of this part, because that's just a normal triangle. We can get the area of the full part, because that's a triangle, and then we can subtract. So the blue area is the area of a triangle, is of course half base times height. I always write out my equations before I go ahead and do these. I know it seems a bit pedantic, but let me tell you, it does help you memorize these sort of things. So the area of the triangle then is 3 times 2.4. 3 times 2 is, of course, 6. 3 times 4 is 12, so it should be 7.2. Yes, of course. I don't really need, maybe I don't need to be checking all the time, but it's good practice. It's good practice to check. So I'm gonna model some good practices here for people. So trying to find the red area, so we need the blue area first. We're also going to need the green area, or the full thing. So the area of the full triangle, of the green one, this whole base here, right? So that whole base is going to be 10, and this side over here is 4. It's important that we use both pieces, right? So then the area of the triangle is going to be 5 times 4, which is 20. So then the area of the red section is going to be 20 minus 7.2, right? Because it's the full 20, subtract the 7.2 that's going to be in here. And we're going to get the area is going to be 12.8 centimeters squared, right? 12.8 centimeters squared is what we end up with for that one. So it's a good question because you have to think a bit about, well, how you can approach the question with the tools that you have, right? Which is sort of my barometer or my meter stick for determining if it's a good question or not. Sort of how many of the tools that you've been given do you have to apply? And here, quite a few. So that is a good one. I have defined that one as a good one. This Master Shake asks us to define good one, and that there is a good one. So now I'm going to go back over to page 183. 183 in the same book. Let me zoom in a bit here. Okay, so I did some similar ones to this page on the last stream, but today I want to do some of these specific ones. 2b, 3b, and both parts of question 4. So 2b is going to be this guy over here. Let me zoom in a little more, a little more. Rid of mo and rid of mo. Whoop, that's my name. Why is that coming up? No, I don't. Get it out of here. Get it out of here. My name does not need to be there. Y'all knew that. Why the heck? Okay, so now I'm, boy, got to remove that picture from my desktop. Okay, slide this one over here. Yeah, that's good. Okay, so this is now page 183, and I'm going to do question, this is 2b. 2 and b. So we've got a quadrilateral here, but this one is what we call looks like to me to be a trapezoid. Trapezoid being, it has one pair of parallel sides, but the other two sides are not parallel. So what we have is a rectangle and two triangles. Right? We're told at the top that this is 6 centimeters, and we're told over here that this is 4 centimeters. We're told that this distance here is 2 cm, and this distance here is 1 cm. So the two triangles on either side are not the same size. So the area of the rectangle, or the part in the center, well, that's easy. That's just 6 times 4 is 24 square centimeters. And now we just have to break down each of our triangles that we have. So the area of the left triangle, I'll call that, area of the left triangle is going to be the base, so it's a half, base times height as always, a half times 2 times 4, so that's just going to be 4. And the area of the right triangle is going to be, I've already written that out over there, so a half times 1 times 4, which is going to be 2. So then our area total, right? Area total is just going to be all those guys added up. It's going to be 24 plus 4 plus 2, so the area total is going to be 30 centimeters squared. Right? All we're doing there is just taking the shape and splitting it into 3 smaller shapes that we know how to find the area of each of them. Scroll down a little bit over here. I'm going to go on to this next one. This is a good one. Oh, striking my camera. So that is Math 2017. This is still PMB, Prism Math Blue. And this is now 183, 3B. Okay, really good question, because there are 2 ways we could solve this one. And the way you might think to try first is actually a lot harder than what you need to do to solve the question. Right? We know that this distance, this one here, across the middle there, that is 4 millimeters. This whole side is 8 millimeters. We're told this is a right angle, which is good to know. And this side is 6 millimeters, and the top is also 6 millimeters. Okay? So there's 2 different ways that we could approach this one. One's a lot more work, and one's a lot less work. The one that's a bit more work, I'll show you first. I'll do that one in red, as if this imply that you should stop. No. This way works totally fine. You can split it like so. Right? Down there like that. But now we've got to figure out, well, what's this distance? What's the side of the triangle there? Well, we know that, oh, am I dropping frames? I was for a second there. I was dropping frames for a second, but I think we're back. I think we're back, Twitch chat. It's good. Okay, so we know that this is 6 across the full top. This is 4 across here. So the difference of this part over, This has got to be 2. It's got to be 2 millimeters there. All right, just let me divert my attention for just a split second. Um, okay, that's super important. Folks, you know that if you contact me about your attendance during stream, I do see it, right? But I will get back to you afterwards. And of course, the email, Skype, and stuff, those are our official channels, right? This is simply, a public math tutoring stream that anybody of any school can come in and ask me questions, and I will do my best to answer those. But I will, of course, get to them in order, right? So the ones that I've already got are already in to get to first. But anyway, so this little triangle up here is going to be 2 across this way. And what's the distance going to be down this side here? Right? We're actually not told very well what that distance is. We would have to assume that it's 4, right? Because we have to assume that where this is a right angle, we have to assume that it's in the middle here. But the problem is that is an assumption that we're making. So even to do this question in general sort of requires us to assume that this is going to be 4 millimeters here for this side, another 4 millimeters here, and another 2 millimeters here. So the red method does take a bit of we're taking a little bit of leeway with what the question is actually showing us. But then the area of the triangle is going to be a half base times height. So the area of the triangle is going to be a half times 2 times 4, which is going to be 4. But of course, there's 2 triangles, right? Well, what else is there? There's triangle plus rectangle. So area total is going to be triangle plus the rectangle. And what's the area of the rectangle? Or the area of the rectangle now, we had to know that the top, it says 6, but we're not going to use 6, are we? Because this 2 here, this 2 millimeters of the 6, that's now part of the triangle. So we can't count that again, right? And that's one of the issues here. One of the issues with answering this question in this sort of a manner is that it introduces more possibility for mistakes. But we have to remember now that the top is actually going to be 4 and the side is going to be 8, right? So 8 times 4 is 32. So then down here, t plus r, because there's a triangle here, and a rectangle, it's going to be 4 plus 32, or it's going to be 40. Right? That's one way to handle this question. Now, if anyone's watching who has done this course before, you might recall what I say for the easier way of doing it. The easier way of doing it, that I'm going to do in green, is to imagine a triangle over here. Imagine this guy was actually a triangle. Right? And if this was part of the shape, well, then what do we have? Right? So we have now the area full shape. The area of the full shape would be imagining that it was just a full rectangle over here with this other triangle bit added on. So that's now going to be 6 times 8, right? 6 times 8 is 48. Right? So, but now we have the area of the triangle. What's the area of this triangle over here going to be? Well, we know that this whole side is 6, right? And this is 4. So we know that this part here, this is going to be the height of the triangle, which is going to be 2, because 6 minus 4 is 2. And we know that the bottom is 8. So the area of the triangle is going to be half of 2 times 8, which is just going to be 8. So then the area of the shape is going to equal 48 minus 8, or the area of the shape is going to be 40 millimeters squared. Okay? So that's, yeah, it's 2 different ways of solving that one, but you'll get the same answer either way. Now I'm going to go down and do both parts of question 4. Then Renetta, that'll be, I think that'll be all the questions that you needed me to go over. And then I'll go on to the one that Esther just asked about. So now we're going to find the area of this guy. Okay, so this is now for A. Okay, so we've got a square nested inside of another square. Now again, one of my pet peeves with Prism Math is that they don't indicate. They don't properly indicate when something is a square. They haven't indicated right angles here, and they haven't indicated, but more importantly, they haven't given us a notation to see that all those sides are the same length. So when I draw my diagram here, I'll show you what you should be using. But we should be using sort of a series of notches, right? Like say if this is 4.5 cm here, we put a 1 notch there, and then we put a 1 notch on the other sides that are also 4.5. And then if this one here is 6 centimeters, I'm going to put a double notch there, and then I'm going to put a double notch on any side that is also 6. All right, so that is the way that it should be represented if they want to show that these are actually squares. Okay, so in your diagrams, or in the future ones that you'll see in your level 3 courses, I will expect that sort of notation. So the area of the inside, right, the area of the inside shape is going to be 4.5, 4.4? Pretend I can write 4.5 squared, right? And I'm not going to do that one in my head. 4.5 squared, 20.25 cm squared. The area of the outside shape is going to be 6 squared, which is of course 36. And then let me do it in, yeah, I'll do it in red like this, because this is what they wanted us to find, was this area here. So now the area of the red is going to be 36 minus 20.25, which is going to be 15.75 centimeters squared. There we go. Right? Because you're just doing the big one, you're subtracting the little one. Over here now, we have another situation, right? It's the same sort of deal though, isn't it? It's the exact same thing. This is shaped like a washer. Oh, that's what I should have done. I've definitely got some of them out of a drawer someplace. I should have went and grabbed a washer and used it as a stencil. It would have saved me a little bit of work. Speaking of gear like that, my shed is almost free. Oh, Twitch chat, it's so great. I'm going to be able to get out there. I'm going to be able to get my barbecue. I'm going to be able to get my my other snow shovel, my big snow shovel that's been trapped in there all winter. I really could have used it this winter. We had a whopper amount of snow in St. John's this winter. But I'm going to be able to go out and get my yeah, go get my supplies basically out of the shed. Looking forward to that once a little bit more snow melts. I can almost get into my backyard already. We have had a ridiculous amount of snow in St. John's this year, and where I live, with the part of the city I live in, gets even more snow than the average part of the city. So we have gotten dumped on, let me tell you. So, not super accurate circles, who cares? So here's the center. So then this line, from the center to the outside, that one there, as they indicate, is 9 meters. And then this one, from the center to the inside circle, that one is 3 meters. Okay? It's a little bit small on there, but you can see it over there on the side. So, now the area of the outside shape, we'll do that first. Area of the outside shape is going to be pi times radius squared, because it's a circle. So it's going to be pi times 9 squared, which is 81 pi. And like I've told you before, in some courses we're just going to leave this like this, right? And in terms of pi, I'll call that. So I'm going to tell you what, I'll do that here. I'll do that now. I'll leave that as 81 pi. Then over here, if we've got the area of the inside, that's going to be pi times r squared again, which is going to be pi times 3 squared, which is going to be 9 pi. Right? And then if we want to find this area, which is what we were told to find, right? This one here. So the area of the green section is going to be 81 pi minus 9 pi. So the area of the green is going to be 72 pi. And again, right, in some courses, you would just leave that like it is, 72 pi. And that's totally fine because pi is a known number. It's not a variable or anything. But I'll go ahead and get it into a decimal because that's how you're doing it in this course. So 72 pi is going to be 226.2 square meters. And there you go. There we have it. That is the topics I wanted to get to in Prism Math 2017. Let me take one more bite of my delicious. Mm. Mm. Toast with partridge berry jam. Let me tell you, that is my mom's partridge berry jam, I believe. It's good. Well, I'm glad that helped you, Renato. Let me know at any point if you got any questions, and I will try to get to them on the next stream. So, Esther, you asked for, I believe I've got your unit open already. Here it is. I do indeed. Let's scroll on down now. You were looking for question 3D. Move the highest and lowest values and recalculate everything. How did removing the highest and lowest values affect these measures? Okay, well, I haven't done question 3 for you yet. So I tell you what, I'll go over the full question 3. I'll do A, B, C, and then D. And then you can see, sort of follow along with the first 3 and see if you did those right. So this is Math 3102A, and I believe this is Unit 2. And this is going to be page 85 in question 3. So let's just, let's go and do that whole shebang there. So 3A asks us for the range of the data set. Well, like I said, right, range is just range. Oh, range is going to equal largest subtract smallest, right? Excuse me. So then the largest here looks to be 4.6. Yeah, that's right. 4.6. The smallest is that 2.7 is the smallest? Oh, 2.6. Yeah, 2.6. So the range is simply equal to 2. Growth in centimeters, so 2 cm. Right? Easy stuff. So let's see here. Now, B. B is asking us, what are the measures of central tendency for the data set? Okay, so in this course, if you're asked for measures of central tendency, that means there's 3 things you got to do. You got to do mode, you got to do median, and you got to do mean. Right? So what I'm going to do is first, before I do any of that, I'm going to write them all out in order because they have to be in order. They have to be in order for the median, and the mode is a heck of a lot easier when they're in order as well. So I'm going to write them all out. So I'm going to do 2.6, 2.7, another 2.7. There's also 2.8s, 2.8, 2.8. There's no 2.9s. There's one 3.0. Let's see, there's a 3.1. There's a 3.2, a 3.3, and then it jumps all the way to 4.6 by the looks of it. Yes, and then it jumps to 4.6. Okay, so the mode, easiest one. Actually, let me, I'll write mode here in red. Right, so the mode, which will be in red. Well, how do we find the mode? Well, the mode is the most common one, right? So which ones here are the most common? Well, there's 2.7s, 2.8s, and that's it. So the mode is 2.7 and 2.8. Right? So the median, well, the median is the middle number in order, right? And how many numbers do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we do n plus 1 over 2 to determine which number out of the set in order is the one that we're looking for. So here that's going to be 10 plus 1 over 2, which is going to be 11 over 2, which is going to equal to 5.5. I know I'm going across with this. It's a bit undisciplined, but, you know. So 5.5, what does that mean? There's no 5.5 number, right? There's no 5.5 number. That means we're looking for the number that's in between entries number 5 and 6. So here, 1, 2, 3, 4, 5. 5 is 2.8 and 6 is 3.0. So those are the two numbers that we're looking for a green one, for the median. So it's going to be 2.8 plus 3.0 divided by 2, right? Which is going to be 5.8 divided by 2, which unsurprisingly is going to be 2.9, because of course that's in between there. So our median now is 2.9. Even though 2.9 is not in our set anywhere, it works out to be the median. And the last one here, the mean. Well, I'm going to write that out again, just to show you the notation I'm going to use. Sigma n over n. Sigma again means sum of. It's not a way that you'll see it written in this course or anything like that, so don't sweat remembering this symbol, but this is how you would see it written later on, and that is what that symbol means. It means sum of. So the sum of all n divided by n, which is the number of numbers, the same as it was up here. So here, we're going to go ahead and add all these guys up. I'm not going to write that out by hand, but I am going to show you on my good pal TI-84 over here. I need to name my TI-84. What's a good name for a calculator? Data? It's not bad. Call it Lieutenant Commander Data. Maybe just call it Brent. My good pal Brent. Lieutenant Commander Brent Spiner. All right, so that is going to be 30.8. 30.8 divided by 10, which is going to be 3.08 or 3.1. Okay? So now we've got the mean, the median, and the mode. In this case, the mode happens to be kind of similar to the median, right? It's a little bit lower, but the mode, like I've said a whole bunch of times before, the mode is not a great measure of central tendency in most cases, right? And here, right, it is, and the mode is even a product of the tool that you're using to measure. For example, is this one exactly 2.7? Or is this one like 2.69 and this one is 2.71? Well, they rounded both to 2.7, but are they the same for purposes of the mode? Right? We don't know. And that's the thing that you'll get onto later in, say, science courses if you were to do them, or anybody who does science courses, called significant figures. Significant figures relate to the precision of the instrument that we're using to measure. And is the fact that whenever we're measuring something, there is always an amount of unknown, because that amount of unknown is sort of past the finest gradation of our tool. But anyway, that's the one thing. The one thing I like way better about the previous math program that we had, because we updated it a few years ago since I started this job. And the new program is better in almost all regards, but the old one covered measuring technologies more. We had to do a set on micrometers and calipers. That was quite fun. That was a good chapter. I missed that one. Anyway, so that is question B, the measures of central tendency for the data set. Done. C, identify any possible outliers. Ah, well, what are the outliers here? I think you might be able to see those already. Right, identify any possible outliers. The horticulturalist wants to write a report on typical growth of this type of plant. Should she remove the outliers before writing the report? Explain why or why not. Well, of course, because it's right there in the name. She doesn't want to write her paper on the exceptional growth of the plants. She doesn't want to write it on the maximum possible yield of the plants. She wants to write on the typical growth of the plants. And if one plant is 4.6, while the rest of them are down around 3, is that 4.6 typical? Well, of course it's not. So remove outliers because it's not typical growth, right? And this goes back to the one that I mentioned about the hockey one, which I can scroll up to actually, just as an aside, because I believe it was only just a few pages before this. Here it is. Here it is, yeah. So this one here, when I was talking about this question about hockey, Here it asked if we should remove the outlier, and there the answer was no. The answer was no here because what are we dealing with? Well, we're already looking at the 7 highest scoring players in the season. We're not looking for the average player. We're looking for the highest scoring one. So we're already dealing with outliers, right? So someone who is an outlier amongst the highest scoring players is a perfectly normal data point if we're already trying to look at the people who are doing the absolute best, who are really pushing the limit, right? Down here, though, because the horticulturalist is concerned about the average growth of the plants, then we're going to have to get rid of the outlier because that outlier is not average growth. And this is a good one to yammer on about because it drives home a point that I make about statistics questions a lot, is that there's a lot of math involved, but also you have to understand sort of the situation that the math is representing. Stats is frequently a lot more conceptual than just than like say normal math computation. And in this case, you have to understand, sort of the goal of what this person is doing to understand if she should remove an outlier. And in this case, yes, get rid of it. So now, then, we'll go on to part D, which, Esther, I believe is the specific one that you were asking about. Part D says remove the highest and lowest values and calculate the range, median, and mean. Okay. Well, actually, let me write out D in black over here because I wanted a different color other than blue. Okay, so we're going to remove the lowest and the highest value from the data set. Well, that's what we get. That's what the trimmed mean is mean when you remove outliers. Or in this case, we're going to remove one from both end, right? I'll write that down too. We'll remove one value from both ends of the set. This gives us a sort of regimented way to find the trimmed mean because we know which numbers we're going to get rid of. So we're going to get rid of this 4.6 and we're going to get rid of this 2.6 because that's our lowest value and our highest value. So now we're just going to go ahead and find, they didn't ask for the mode, but the mode is, well, I'll write down the range first because they did ask for the range. The range now is going to be 3.3 minus 2.7. So the range is now going to be 0.6. Wow, that changed a whole bunch, didn't it? Look at that. Over here, the range was 2 in the original set. Now the range is 0.6. It's a heck of a lot less. Our mode, even though it doesn't ask for it, our mode is unchanged. It's still 2.7 and 2.8. Didn't change that at all. Our median, well, the median now is going to be, it's still going to be n plus 1 over 2, right? But that n plus 1 over 2 is now, instead of being 10, it's going to be 8 plus 1 over 2, which is going to be 9 over 2, which is going to be 4.5. So the 4.5, 4.5th one, 1, 2, 3, 4. Wait a second. Wait a second. It's the same numbers. Why is it the same numbers? Well, it's going to be the same numbers because we've taken one number off the front, off this side, and one number off this side. The median is simply the number that's the middle of the set, right? And if we take off the same number from this side and from this side, the middle is going to stay the same. It's still going to be right here. So our median is unchanged. It's still going to be 2.8 plus 3.0 over 2, which is going to be 2.9. There we go. Our median is actually the same. Now the mean, right? It's called the trimmed mean for a reason, isn't it? It's called the trimmed mean because the mean is the one that's going to change. I mean, the mode could also have changed, which is one reason why they didn't even concern themselves about the mode. I'm just going to cross that guy out. So the mean now, it's still going to be the sum of the n values divided by the number of n values. But here now, we're going to have a much different sum, aren't we? So let me bring up Lieutenant Commander Brent Spiner. 2.7 2.7. It's important to amuse yourself, right? Like that's one thing you learn doing any sort of comedy or performance or stand up or stuff like that, right? Is that as long as you're making yourself laugh, who cares? Right? It's going to be 23.6 divided by n, which is now going to be 8. 3.6 divided by 8 is going to give us 2.95. Very close. Very close to 3. But look now what happened, right? So look at these values. Before, our mean was quite a bit more than our median, right? It was about 3.1, median was about 2.9. And also before, the mean was actually a bit above average, wasn't it? Like the 3.1 is bigger than most of the plants, but it was still considered to be the mean plant. And it was considered the mean one because of this 4.6, right? But now that the 4.6 is gone and this original 2.6 with it, the mean and the median are almost exactly the same, right? That's one way, that's one sign that what we're doing here is a better value for the central tendency than what we had before. How did removing the highest and lowest values affect these measures? Well, median was unchanged. Range is significantly smaller, we'll say. Then we'll also say mean is now close to the median. All right. Math 3102A, Unit 2, question 3. So, Esther, I hope that answers the questions that you had on that topic. If there was anything else that you wanted me to go over on that one, you can drop that in chat as well. I know before you mentioned question, I think you mentioned question 4, but question 4 is not a super difficult question. You can just sort of make that one up, right? Because it's just find or create a data set with no outlier. That's not hard. Just have like 6 numbers that are all very similar. Find or create a data set with one outlier. Have 5 similar numbers and one that's way different, right? It's that's a fairly straightforward one. So let me know if you have any other questions, and I'll get to those. Um, yeah, hope that helped for today. Now I didn't get to these ones yesterday because I sort of ran out of time. Oh, I don't have to do 4. You had to do 5. Okay, let me see what number 5 is. Uh, Jack is the manager of a fish processing plant. Records the number of cases of processed fish by the plant each day. Number of cases are that. Determine the range, median, mean, outliers. Okay, that's a good question. Yeah, that's a straightforward sort of central tendency one. How about you try that one and let me know if you got any difficulty, and then I'll get to that one on Monday's stream if you have any problems with that. But this is a good one because it's pretty similar to the one that we just did. So hopefully now that we've done that last one as an example, you'll be well equipped to go ahead and handle that one. So right now I'm going to pivot over. Um, Brittany, I don't know if you were in chat, but I know yesterday you asked me to go over these ones. Now, should be okay? All right, Esther, yeah, great. Well, just let me know if you got any questions, because yeah, I'm always here to read them, although I might not, like I said, I might not get to them until the next day sometimes. So Brittany asked me for this page. Now I couldn't do it the same stream because where I only have the answer key for these guys, I got to go and make sure that I've blacked out the blacked out the answers to the questions. But I'm going to go through and do a few examples. I'm not going to do all the examples. Have a good weekend. Yes, you too. Yeah, I hope you stay safe and yeah, don't work too hard on your math. You're doing great for that. Just yeah, make sure to take care of yourself out there. And don't go stir crazy. Find something fun to do. Apparently, there's been a real run on puzzles, right? Like people are going out and buying massive jigsaw puzzles. I'm uh I'm gonna spend a lot of tomorrow cooking, I think. I've got yeah, I had to open up a can of soup again today for lunch. Boy, I'm run out of nice home cooked stuff, so I'm gonna make some more the weekend. Although I did have a can of Irish wedding, not Irish, Italian wedding soup today. So that's nice. Some outside working around the house cleaning. Yeah, it's a great time for that. Absolutely. Yeah, gotta keep busy and keep interested, right? So this is going to be Prism Math Purple, um, page. What is this page? 243, and this is Math 2020. Right. So Prism Math Purple, page 243. Yeah, I'm going to do a few examples. I'm not going to do any of the B's. I'm just going to do some of the A's as examples. So here it says, write the operation that would undo the operation in the equation. That would undo the operation in the equation. Well, it's oddly phrased, isn't it? But all you got to do there is say what the opposite is. So like, if you were trying to get rid of that minus 16, what would you do? You would just add. I would even say add 16 as the answer. That's it. That's all they're looking for. These first few ones are super simple. Like I've said a bunch of times, the Prism math books are good at like adding a little bit of complexity on each time. So sometimes if you get to a question and you think, how could it be this easy? Like, why is it asking me to do something this simple? It probably is. It probably really is asking you that. Say 12 would be, so 14 equals n minus 32. So it's just going to be add 32. We got to add 32 to get rid of that minus 32. Right? So I'm going to go question 3. Question 3, solve each equation. Now this is what we call one-step equations. Those are what these are. So these are one step. One-step equations are just algebra equations, or in this case, pre-algebra is what we technically call it. But they're, like it says at the top, algebra readiness, right? It's pre-algebra in the sense that it's getting you ready for algebra. But here, all we've got to do is solve these equations. N minus 7 equals 12. Well, to solve an equation, solve means to get the variable by itself on one side of the equations. So to solve, we just got to get rid of this minus 7. We can move anything around in the equation, but it becomes its opposite, sort of. So one way you can think of it, and it's the way I like to introduce it, is to think of it as like, once it crosses over the equal sign, it just becomes the opposite of what it was previously. So n equals 12 plus 7, because plus is, of course, the opposite of minus, so n equals 19. Right? I'll do questions 4a and 5a there, and then I'll move on to the next page. So a minus 11 equals 6. So again, we got to move this part over here. You don't have to draw those arrows. I'm just going to keep doing it. So you guys can see what sort of the nuts and bolts of it is that we're doing. A is going to equal 6 plus 11. So A is going to equal 17. Right? Then question 5. X plus 9 is equal to 18. Well, this 9 can move over, so then it becomes 18 minus 9, or just x equals 9. It is important to know that the way I'm writing these out is the way that you would be expected to write it, with the exception of the arrows. You don't need to draw those. But do go down the page in general and have one equal sign per step. Right, so I'm going to go on now to page 244 over here. Right, so that's going to be the next one. Page 244 then looks like this one. Solving algebra equations using multiplication and division now. So let me zoom in a bit. Right, so this is going to be very similar to the previous page, So I'm going to go ahead and do just a few here, but they're a little bit different because there's a few more cases that we had to deal with, but it's all still very similar. So now, question one, write the operation that would undo the operation in the equation. Well, it's 6 times a equals 24, so we got to get rid of that 6 times. So it's just going to be divide by 6. Okay? Kind of alternate between green and blue here now, so we can green and blue, green and red. Pretend I know my colors. I'm not a kindergarten teacher. I don't need to know my colors. It's already, I can just forget about that now, right? It's like students, right? At the end of the unit, at the end of the course, they're like, oh, well, I don't need to know that for next year. I'm just going to forget that. Well, me, right? I don't teach kindergarten, so I don't know my colors. I forgot that. I learned it in kindergarten, and I was like, I'm not going to need this again. See ya. Colors out of the right. Just anyway. 4 equals n over, oh, right, this is not what we need to do to write out these ones. We just need to say what we're going to do. We don't even need to do it. Never mind. It's just multiply by 3, right? Because that is n divided by 3. So to get rid of an n divided by 3, we've got to multiply by 3. Question 3. And this one is going to be, guess what, Twitch chat? Divide by 8. There you go. Nothing to it. Number 4 now. With number 4, it starts to be a bit more real because we had to solve the equation. Still not very difficult because these are just one-step equations. Right here we've got x divided by 3. To solve that, we have to multiply. So it's going to be x equals 4 times 3. Like I said, I use a dot in the middle to mean multiply. So x equals 12. You can think about it too, as if you go back and say, well, what's 12 divided by 3? 12 divided by 3 is 4. It's one way you can check algebra questions like this, right? Or pre-algebra, whatever. X times 12 is equal to 144. So now the operation is divide, right? The opposite. So it's going to be 144 divided by 12, which means x is going to also be 12. Because 144 is a special number. That's a gross, we call that. It's a dozen. It's a good number. Do you know why baker's dozens are 13? Chet, do you know why baker's dozens are 13? I'll tell you why. Well, I don't know if it's actually true, but I read it on Reddit at one point, so it's got to be true, right? If you read it like just randomly in some Reddit TIL, it's got to be true. But it was because bakers they would often sell their goods by the dozen, but they didn't want people to complain if they got one that was too small or several that were too small or whatever, because it would always be some difference. So they would put in an extra one, right? So if you opened your bag of bagels or whatever, and you found that like 2 of them were small, but you actually had 13 instead of 12, and you're not going to complain about that, are you? No, of course not. So that's why baker's dozen became 13, because even though you promised 12, you'd get 13. That's going to smooth over any problems that people would have if they thought they were like shortchanged because one was like 3 grams too small or something. Anyway, so number 6 is x over 8 is equal to 24. So that's x divided by 8 is equal to 24. So the opposite of that is going to be multiply. 24 times 8. 2 times 8 is going to be 16, so it's 160. 4 times 8 is 32, so it's 192. There we go. And yeah, I don't need to do question 7, I don't think. I think this is getting fairly good here for explaining how you do these ones. And I know the student doesn't appear to be in chat, so I don't really know if it's going well for them. But that's what VODs are for. Hey folks, watch me VODs. That's right. Twitch likes that, I suppose. Yes, boy. I suppose now it's marvelous. Marvelous you watching me VODs. Okay. The next thing I want to do is the next page in the book goes on to solving 2-step equations, right? And I do want to show some 2-step equations. However, oh, that's a nice one. I don't necessarily want to do the exact 2-step equations out of the book, So I'm going to do some, just over here, some examples of two-step equations that I got from um, mathaids.com. Okay, so I'm going to do maybe, I'm going to pick a few of these, and I'll just write these out on the sheet over here. So this is going to be um, of two-step. Right, so just over here on the side now, I'm going to do out some examples of two-step equations. I've got some prepped here ready to go. So that way, when the student comes back and watches this one, they can carry on watching up to this point and then see how to do some of the ones for the next topic. Let's say number one on this sheet that I've got here is 17c plus 3 equals negative 5. Now, excuse me, these ones are considerably they're a bit more complicated than the ones in the book because they're not going to work out as evenly. But the thing is, like, if it works out evenly or not, that doesn't make it any harder. It just makes it sometimes a little more intimidating because you're like, I got my answer is like 41 over 17. Could that possibly be right? But guess what? Sometimes it is. Sometimes it can be right. So what I'm going to do here now is move each part of this equation away from the c, because c is what needs to be by itself. So first up, I'm going to move this plus 3. Going to call this 17c equals negative 5 minus 3. So that means 17c equals negative 8. Now I'm going to divide both sides by the 17 here. We're going to get c equals negative 8 over 17. And there's your answer. See what I'm saying? See what I'm saying about how weird it is? Oh, they actually went and turned it into a decimal. So that'd be negative 8 over 17. Yeah, negative 0.47. Okay, I left mine as a fraction. But either way, that is the right answer. Let's do question 2. Question 2 here on this sheet. So question 2 then on the sheet is going to be 7 minus f all divided by 8 equals 12. Ooh, what happens here? This one is a little bit of a wrinkle, right? What happens here? Can I get rid of the 7 first? Well, no, I can't. The reason I can't get rid of that 7 first is because we kind of treat it like there's a bracket there, right? And this 8 is divided by the whole side, right? Because the thing that's important, well, the bracket is not important. The bracket being there is actually not super important. The important part is what's here in the middle, right? This minus. This minus in the middle is important because any numbers in algebra that are separated by a plus or minus are different terms, right? So this 7 is a term, and this negative f is a term. And when you have multiple terms divided or multiplied by the same number, you have to remember that this divide by 8 happens to the 7, and this divide by 8 happens to the negative f, which means it's happening to the full group up here. I could go ahead and write this as 7 over 8 minus f over 8 equals 12, and then start trying to solve it like that. I could. That would be a bit more work, though. What I'm going to do is I'm going to get rid of this divide by 8 first. So now I'm going to call this 7 minus f is equal to 12 times 8. So 7 minus f is equal to 96. Right? And this one here has a few steps in it, right? Because now I'm going to move this 7, because this 7 over here doesn't have any sign in front of it, right? So what do we treat that 7 as? There's a whole lot of stuff going on here at once. Well, the 7 is a positive, right? Because if there's no sign in front, we know that means it's positive. So when that moves to the other side, it's going to be 96 minus 7. And it's super important, super duper duper important, and a really easy mistake to make, that we have to leave this minus here in front of the f. Even though it looks like now it's like, well, we're not subtracting it from anything. What the heck does it mean? Well, it means that the f is negative, is what it means. So it is important to leave that negative sign there. So we have our negative f equals 96 minus 7, which is going to be 89. And we're almost done now. We're almost done. But we have to get rid of this negative here. How do we get rid of the negative? Well, what we're doing is we're going to multiply both sides by -1. Is kind of what we're doing, right? Because multiplying by -1, all that does is change the signs of sort of everything there. So I'm going to multiply both sides by -1. I'm going to have positive f equals -89. So that's the answer for 2, and you'll see that is correct if I scroll down here. F is equal to -89. Okay? Took us a little while to get there, but we got there in the end. So I'm going to do 2 more of these guys. I think I'm going to do, what's good teachable moments here? I'll do 4 for sure. Question 4 then, right, is 1/8 of v plus 21 is equal to 20. Okay, so first up, I'm going to get rid of this plus 21, because that's the easiest one. I can just sort of move that away. We get 1/8v is equal to 20 minus 21, or 1/8 of v is equal to -1. Right? But this is 1/8 times v. What do we do when it's 1/8? Right? Well, there's a whole bunch of different ways that we can think of this one. We can think of it that it's v divided by 8, which it is. We could also think of it as v multiplied by 1/8, which it also is, because multiplication and division are kind of the same operation. But if we move a fraction over, it's going to flip and it's going to become its reciprocal. But another way that we can think about the algebra that we're doing here in these equations is that, like I did down here, we're multiplying the left and the right side of the equation by the same number. Because if we do the same thing to the left and the right, then we can do it, whatever it is we're doing. So what I'm going to do here is I'm going to take the left side, and I'm going to take the right side, and I'm going to multiply them both by 8/1. So I'm doing the same thing to both sides. Why am I picking 8/1? Well, because 8/1 is the reciprocal of this fraction. Because then what's going to happen? Well, this is going to cancel with this, and I'm going to be left with just v on the left, which is what I want. Just v is now on the left, and on the right we've got -1 times 8, which is -8. So if I was to scroll down over here, v equals -8. There we go. Good stuff. So I'm going to go ahead and do one more. I'm going to do question 5 on this sheet. Now again, Brittany, you don't have these ones in your book. These aren't in there anywhere. This is just an example of the extra work that I would provide if you asked for more practice. But it's very similar to the topic that you're going to be starting on, I believe, page 245. 6/7s is equal to 13. Right? So I want to get this -11 out of there. I can imagine like I'm moving it over to this side. But let me just show you, in keeping with what I've been doing in these past 2 ones, let me show it to you in the way of thinking that we're doing the same thing to both sides. Because this is really what's happening. It's really not that a piece moves to the other side of the equation, although it is useful to think of it like that. What we're really doing is adding an 11 to both sides. And the thing is, here we've got a -11 and a +11, so those guys are going to cancel. That was the point. That's why we picked 11. Then we're going to have 6/7s is equal to 24. And now, just like we did up here, we're going to multiply each side by the reciprocal of this fraction. The reciprocal is the fraction flipped. The reason we are going to do that is so that the fraction cancels. Then we're going to be left here with a 24 times a 7/6. That's a 24/1 we can think of it as, of course. So this is going to cancel with this, and this with this, right? That was why we did that one. Over here, 24 divided by 6, well, that's just a 4. So that's going to become a 4. So we're going to have s equals to 4 times 7, or s is equal to 28, which is 4 times 7. Let's scroll down and see if we got that. We did. S equals 28. There it is. All right. Good stuff. Good stuff. So that is Yeah, we're at 2:25 here now. Um, yeah, hope you enjoyed the work today that I've been going over. I hope that has helped everybody. It is 2:55 Newfoundland. I said it was Newfoundland Standard Time before. I believe it's actually NDT, Newfoundland Daylight Time. Newfoundland Daylight Time. My goodness. NDT. Anywho, uh, I am going to, if you're there in chat watching, thank you very much for being here. Super appreciate anyone who's along to watch. I am going to start talking about educational games very briefly. Um, well, the talk won't be brief, but the break will be brief. I am going to very quickly take a short break to go wet my whistle, and I'm going to change my my stream title. Um, yeah, the stream will go down for just a brief moment. It'll be like maybe 2 to 3 minutes it'll be down for. So if you're in chat, please stick around and hang out and you can watch. I'll be going live again momentarily with a new title so that I can talk about some educational games for a bit and sort of be a little bit self-indulgent while also still focusing on my job, my education. Okay, thanks for being with me for the math stream, and I will see you again shortly.